Hi guys, welcome to the Tech Granth. Today we are going to solve the problem of merge case sorted list. Do like, subscribe and share the video and also subscribe the channel to get further updates. Okay, so we have to merge case sorted linked list and return them as one sorted list. So if we see here, we have input as 1, 4, 5, that is the first linked list. Then we have 1, 3, 4, which is second linked list, and 2, 6, which is the third linked list. We need to join all these three in a sorted order, and the output will be this 1, 1, 2, 3, 4, 4, 5, 6. Okay. So, and we don't have any constraint given here or any complexity in which we have to do. They just say you analyze and describe the complexity. So what we can do here is we can follow an approach of like two loops and keep on merging and then adding the list to a new list kind of thing, but I think we can do better time wise. So the approach I'm going to discuss here is again based on merge sort. So I'm not sure whether you guys have gone through a problem where we flatten a linked list. Basically, we have a two-dimensional kind of linked list and we have to flatten it. So I'm going to apply similar kind of approach here. I'll start with the first list. I will merge it with the second one, and the result that I get, that I'm going to merge with the third one. So this will take a time complexity of order of n, where n is the number of nodes in this particular input array that I'm getting. So just let me show you the approach here. So what I'm going to do is I have three linked list here. So I will merge sort these two. Whatever result is there, I will store that result, and that result I will merge with the third list that is there as part of the array that is given input to me. So whatever result is there, so I'll keep on going till the end of the array, and once all the lists are there, so my final result will be stored in some variable like result here. Now one question comes here is like, since this is not a simple array of number or something, it is a array of linked list, so how do we maintain the head of the linked list? Like when we are merging these two, so I need to maintain a head which will contain the minimum number. Like if I merge these two, suppose let me show it here. So if I have like 1, 4, 5, and the second one is 1, 3 and 4. So if I merge these two, so it can look something like 1, 3. So if I start merging these two together, so it should be like 1, 1, 3, 4 and 5. So next time when I merge this with the next array that is there, which is 2 and 6, so how do I make sure that the result array that I'm getting is does not start with 2 and then keep on adding 1 or 3 kind of thing? So there is a little trick for that, and the trick is your pointers. Basically I will play around with the pointer of the result, and I will create an initial dummy node which will hold the least value of the data set which I'm going to use. I'm going to use an integer variable. So the first node that I will have, it will have the least value. So when you will see when I do sort merge, that way that node will be picked every time rather than the node coming from all these list or whatever list is given here. So that small trick will do wonders for us. Let's try to solve this problem. Let me just enlarge my screen. Okay, so we need to return this list of nodes. So we'll create a list of node. We'll say result equal to new list of node, and this node will be integer of min value. So this will be a dummy node, and in the end when I have to return, I will say return this result dot next. Basically the next node that will be added to this result will be the actual node coming from the list. This is just a dummy node, and I'll show you going forward how I'm using this node to maintain the head of my result. So let us loop through the array list that we are getting. So we'll say I equal to 0, I less than this list dot length I plus plus. Okay, and we'll create a function for merging where we will merge this lists of I with result. So these yeah, so this is the one. So we need to implement this merge function in such a way so that at the end my pointer starts at the head pointer of my linked list starts at the result. So what I will do is I will implement the merge function. I need to return the list node, and I will say merge, and I'll take two nodes. Basically each of these node will be the head which is coming from list and one from the result. So it's list node A, list node B, and we'll say if A equal to null. If the first list is null, we don't have anything there, so we return B. We return the second list and add it, and if B equal to null, then we return A. So this will make sure that if any one of the list is null, if we have, like when we are doing the merge from two linked list and one of the list is over, because all the lists are not of the same size, so it may happen that this list will be over before this when we are merging. So this condition will take care of that if we encountered a null node, then we will return the other node. We'll create a temp node here, and then we'll do our comparison. So we'll say if a dot val, what is the value? Yeah, it's val. So if a dot val is less than b dot val, it means that the value in the second node, which is b, is greater than value in the first node, so first head of the linked list in b. So if this value is less, so I will say my temp equal to a, and then I will recurse. So where do I get my temp dot next from? So I'll do a recursion to my merge list, and I will pass my first list as a dot next, because here we have added one element from the a, which is the head node in temp, and we'll pass b as it is because we have not done anything in b. Otherwise, in the else condition, the temp is equals to b, and temp dot next is equal to same thing, merge. We'll do a and b dot next. Okay, so once these two cases are handled, we will say return result. So just let me go through the logic here, what we are doing. We got the list, we are just going through the list, and we are merging each of the list with the result. So basically initially my Result was a one node list, which is a temp node with the minimum value of integer, and I will merge the minimum value of integer node so that uh, so on top of the input that we have like 1 4 5 1 3 4 2 6, I have one more node which contains integer dot min value. So I will merge this particular linked list with this list first. That is what we are doing here. And whatever result comes, that result will be merged with the second one, and so on. Now the question is here, if you see, I am not doing anything such that result dot next equal to or something like that. I am simply using my result and just keep on merging my list with that. So how it is possible that it will work, the result will work here? So just let me run this code once. I'm sorry, I think this will be temp. I will return temp here. So it has accepted this solution and we have got the value. So now the question comes here is like I'm not doing anything like result dot next, or I'm not getting the output of the merged list anywhere. It's just this result which I'm passing again and again. So every time it comes. So how we are able to get the output? So the trick here is every time this result is getting passed to this list node, so result will have first node of the output as the integer dot min value. So suppose initially the result was this. This was my result equal to this, and when I merged it with the first list that I got, so I got something like this, then 1, then 4, and then 5. So this is my result value. Now next time when I went and again I did the merge with list, so next list is 134 and the result is this with head as min integer value. So the trick happens here, every time when these two nodes are not null, it will skip the first value here, it will skip a dot val less than b dot val, because the value b, this list node b, will have the first node as min value. So any value that comes as part of input will never be less than the min value. So every time my first cursor goes here, so the temp variable that gets created, the object temp, it gets the value as integer dot min value, which is the pointer to my result. So this is little tricky, but this if you are able to understand this, it will be very helpful, because once you get the value, if you can see the code, it's a very simple code. Initially we thought it will be a very big code for a problem like this, but it's just some 30 lines of code here, and it is all working based on this pointer, and the pointer is being initialized, and it's helping us because of this min value that is being assigned to my result. So since the second, if you see the second list b, this result is being passed to as b to my merge method. So every time when even this one, if this method is getting called, this b is being passed here. So first time, the very first node of b that is encountered, it will be encountered here when we do the comparison. So that is why every time the temp gets initialized with a value of this result. So each time when this merge has happened, when I go and merge for this value, so now these two has to be merged. So 1 3 and 4 has to be merged with this value. So again, if you see here, it will come, since both are not null, it will check a val is less than b val. Here b val is greater than a val, which is false, so it will come here. So temp will have b. So temp will be this list. And then again I will go and we will do b dot next, so it will start from 1 and then it will start merging with 1 and 1, then 1 and 3, 4 and 3 and so on. But this temp variable will be initialized with list b every time, so that is helping us in achieving the result. So let us submit the solution, and it is accepted. You see it's a pretty good time for this list. I think it we can even optimize this, but maybe in other video. But time complexity wise it is order of n, so that is good. So see you in the next video. Thank you.